Welcome, this is ITS128, and today is October 8th, and we are in Chapter 5, studying loops. And let me share my screen. So here's our textbook. Oh no, let me go to the syllabus. Okay, so we are. I want to apologize. I just now um, put class 13 up here. I recorded before I uploaded it. I named the class wrong, and then I forgot to put it. Anyway, it's there now. It's here, and of course in resources right here. So last Tuesday we covered sections 5.1, 5.2, and 5.3, and we went over lab exercises uh, 14 and 16, and these two are while loops. And so basically we covered while loops last time. And so today we're going to continue, and we're going to start by counting using while loops, and then we're going to see that there's a new construct called for, which is a for loop, which helps us count. If what we're doing is counting, it helps us do that much better without um, as easily causing errors. And we'll see how that can happen. Okay, so we're in 5.4. All right, so you remember with a while loop, we have looks like an if. It looks like an if, where you have instead of let me make this a little bigger. Where instead of having if something, then do something, we have while something, do something. And what while is supposed to imply rather than if is that we keep on doing it. Once we're done with the body of the while part, then we go back up and we do the test again. And we keep on doing this until something happens and the test ends up being false, in which case we skip out and continue on. So what this means is that there has to be something inside the loop that might cause, that will eventually cause this condition to be false. All right, so that's how a while loop works. And so here, one thing we do with the while loop is we can count. Commonly, a loop should iterate a specific number of times. Let's say 10 times. Let's say you have a loop and you want it to iterate 10 times. The programmer should use a variable to count the number of iterations, and that would be called a loop variable. And each time you do a loop, you better make sure you increment this loop variable. So here, for example, we're starting out setting I equal to 1, and then while I is less than or equal to n, or in this example be 10, you do whatever is here. And the last thing you do, it doesn't have to be the last thing, sometime in there you want to increment the loop counter. So when you come back around again, this will eventually fail because I will get bigger. It will get bigger than n, and so the loop will stop. A common error is to forget to include this. Okay, that's a very common error. Happens a lot. You somehow, for some reason, you like to put the increment down at the very bottom of the loop because you're all done with that pass, and then you're going to increment to the next pass, and you're going to go up and you're going to see if you're done. I don't do that anymore. If I'm going to have something like this, I put my incrementer right in the next line because I don't want to forget that. But anyway, so here let's see what that would look like in an example. And so let's say we have a program here that is going to calculate how much savings. So let's say you have a savings account. You're going to start out with $10,000, and the interest rate is 5% per year. And we're just going to do 1 year at a time. So we're going to start out. We're going to print out the initial savings of, and this is going to print this out, that value out right here, and so that's going to look like a $10,000, and then it's going to print at Let's see what this looks like when we run it. Savings at, we have the, where does it say? Oh. We started by doing this. We display this out. And so that is initial savings, what, $10,000 at whatever this is, 5 and 0 digits to the right of the decimal point, but we're doing it divided by 100 because we write times 100 because when we think of an interest rate, we think of it in terms of percent, but when we actually do calculations, we need to use the real value of it, and that's actually 0.05. So that's what this does. So that's why we multiply the interest rate by 100 here, because really the interest rate is 0.05, but we want to display out 5%. See? So that's that there. Okay, and then we input how many years we want to do it for, and so when this thing executes, okay, when this line executes, the first thing that is sort of processed, or the first expression that's computed, or however you want to say it, is this here, which is asking the user for an input. It displays this out first. So that's this. It displays this out. And then in this corny little browser-based development system, it accepts whatever you put there, and so that gets put in. We don't see it there, but it's at this point where this thing is red, and then we print a blank line. Where's the blank line? Well, I think it's messed up. What happens if I'm like, can I take this out? Excuse me for my digression here. I'm going to bring up a what's this? New. I'm going to copy this. Copy this into here, and I'm going to save that as test.py on my desktop. And then I'm going to pull up a prompt. CD desktop py test.py, and it asks me for the number of years. I'm going to say 10. Excuse me, I don't have COVID. I drink my green tea. I drink the powdered stuff, matcha, and sometimes I make it too strong. But anyway, so there is an extra blank line in there, which is why I don't really like this development system here, but who cares? Doesn't matter. Okay, so we go through the loop here, and we go through until we hit 10. We print out the savings at year 1, and then we at the beginning of the year. So at the beginning of year 1, we just start out with $10,000, and then and that's this line here, printing out the year number, which is this, along with the amount of the value of savings. Oh, this. Okay, and then then we go a whole year, and then at the beginning of the next year, how much interest we've made is we take the savings and we multiply it by the interest rate. And so if it's $10,000, it's going to be what 0.05 times 10,000, I guess, is 500. So really, this value is 500. So we're adding 500 onto our savings, and so now our savings has a new value of 10,500, and we increment to the next year, and we go up here, and we see is it equal to the number of years yet, which is 10. No, it's not. So we print this out. An interesting thing about this, which I just noticed, is when we're doing the year 10 iteration, we print this out. Then we actually compute a new savings value, which is how much you would have at the beginning of the 11th year. But that never gets printed out, because when this increments to 11, then this condition fails, and we don't get a chance to print it out. We just skip down to here, which prints an extra space, prints an extra line down here, which is why there's so many blank lines down here. So anyway, so that's using a while loop to do the simple counting, where you have some number that just goes from 1 to which goes from 1 up to some value, which in this example is 10. If we made this 5, it would only go to 5 years. Okay, so we could do this. Let's do this. Let's take this, copy this, and let's put it down here. Okay, so now we're going to get that last one. Okay, I'm going to run this. See, now we get that last one. Anyway, all right, savings interest program. Here we're supposed to answer these questions based on the program above. What's the amount of savings at the beginning of year 4? Ignore cents and do not include the dollar sign. This. Copy beginning of year 4. Yeah? All right. Okay. If the interest rate is 3% and the initial savings is 500%, and savings is greater than that after how many loops? Well, we have to modify the program to get that one. So let's make this 3%. And let's make the initial amount be 5,000. Is that right? 5,000. And we want to go up to 7,500. So we would do 5,000. And we would do while, and we wouldn't, this loop would not be looking for I. We're just going to let I go as big as it goes, and we're going to go until savings, while savings is less than or equal to okay. 7,500. Well, I'm going to do. I'm going to do something bigger, like 10,000 here, 5,000 to 10,000. So I'm just going to run this, and I'm going to run this. Oh, we want to go how many years? Oh no, it doesn't matter. So we can just make this go big, and let's run this. And it'll stop eventually. It'll stop when the savings become when do I the savings? Oh, 10. I went all the way up to 10,000. Oh yeah, okay. So and the reason I did the last one is because I included this. Let's get rid of this. I was just showing you stuff. We only have to go to 7,500. Let's go to let's just do 7,500 and see what happens.
Saving is bigger than 7,500.
Yeah. What? I'm sorry. What's your question?
No, the example it says savings should be bigger than 7,500, not less than.
Oh, okay, okay, right. Oh, savings is great. Yeah, you're right. Loop until savings is greater than 7,500. Right. Okay. Sorry. Yes. So we're gonna loop until savings is greater than. Yeah, we're gonna loop until savings is greater than 7,500, and then we're gonna. Yes, right. So while savings is less than 7,500, we will loop. But we want to. Wonder how we. Greater than. Well, savings, because we want to go one more time, don't we? We want to. Well, I'm just going to add this one last line here. Remember, I had this there. So it's going to loop. This is actually this one. So it's going to remain in this loop until savings goes over 7,500. Because while savings is less than or equal to 7,500, this thing loops. Once savings becomes greater than 7,500, because of this, once this makes savings go greater than 7,500, then this fails. So then it comes out, then it exits the while loop, and we have savings, and at this point, savings is greater than 7,500. So what is the year, I guess? And so this should tell us that. Let's see what this is. So it doesn't. Well, this doesn't even do anything anymore, does it? Yeah. Yeah, we don't use years for anything anymore, do we? So I'm not even going to have this. I'm just going to. I don't need that. So let's run and see what happens. Okay. So this is the first year that savings is greater than 7,500, so that's 15. So is that enough to answer our question? How many loop iterations? So I might be off by one now. This is at the beginning of the 15th. So is it 14 loop iterations? Let's see. Okay, this could be. I could be off. I'm gonna put 14 and see what happens. Oh. Each year an iteration. Each year is an iteration of the loop, so it takes 15 years for. Oh, yeah, right. Um, I'm gonna do a little test here. So here's the program I had. Can I make this bigger? How do I make this? I'll use that. Sorry, I'm taking. That's hard to see, isn't it? Well, can you see this? How do I? Oh, zoom in. Control, mouse, wheel up. Oh, control and then mouse wheel up. Okay. Oh, yeah, that's better. Okay, I'm gonna I'll tell you what. I'll wait. After this, we're gonna learn for loops, and so I'm gonna try this again with a for loop, and I'm gonna see if it's 14 or 15. I guess it is. I said 15. Right? That said is the answer. Yeah, I'm sure it's right. Anyway, so that's how off by one can get messed up in your head. And the thing with programming is that you can try it and you won't break anything. So you just try it, and if it's wrong, oh, try to change it, and no one sees you, and it's just it's a lot. It's always faster. Well, actually, when you're younger, you can probably uh, do it better. Do it better in your head. I may have mentioned before that when I first started programming, well, we didn't have this. It wasn't so easy to iterate, to make little changes and see the update of your program until we were able to start writing programs with a keyboard and get immediate response. When I started writing programs, we had punch cards, and so you couldn't even do them. But then we got what were called teletype machines, and we were able to type in our program and then run our program and make small changes. But after a while, so in the old days, you just had to sit there and stare at your code and you work it out in your head. But now with this stepwise refinement, iterating through your programs, which actually is covered in this chapter a little later, before the end of this chapter is over, we're going to talk a little bit about that, just that in itself. Um, it becomes easier. It's like trial and error, and you aren't breaking anything by trying. So you can answer these questions and each use this in each answer. Iterate 10 times while I is less than or equal to 10, I guess, is what they want here. Okay, so anyway, you can go through these. So, and maybe you'll have an off by one error. Okay, so other forms of counting. Counting down is also common. So here we go from 5 to 1, starting out at 5, and each time we decrement by 1. Same thing. Here we're going in, we're doing even numbers. We start at 0, we go to 2, 4, 6, 8, like this, because each time we add 2. And so this is only going to loop 50 times or so. Loop over presidential election years. Write a program that prints the U.S. presidential election years from 1792 to present day, knowing that such elections occur every 4 years. So we initialize our loop at 1792, and we say whatever the current year is. Let's say it's 2020, just or whatever. While the year is less than or equal to 2020, print the election year, and year equals year plus 4. So it looks something like this. There they all are. How many of them are there? How many of them are there? I equals 0. I equals I plus 1. I comma year. There are 58 of them. All right. Loop iterates over odd integers from 1 to 9 inclusive. I equals I plus 2, because odd numbers come every 2, just like even numbers. So that should do that. This loop iterates over multiples of 5 from 0 to 1,000. So this is, you know, I is less than or equal to 1,000. I think. I equals minus 100. Okay, you can do this. Calculate factorial. So what factorial is you start with n, and you multiply it by n minus 1, and then multiply it again by n. So in other words, if you start out with 5, take 5 and you multiply it, you do 5 times 4 times 3 times 2 times 1, and that's what 5 factorial is. So we're going to read in a number, 5, and we're going to start out and we're going to compute what total is. So we're going to start out, we start out with n equals 5, and then we're going to multiply it by 4, and then we're going to multiply it by 3, and then all the way down to multiplying it by n. Well, yeah. So while I is less than, while I is greater than 0, I equals I minus 1. Equals I minus 1. And here we're going to say total equals total times well, I'm going to try this. N minus I. That'll do it. Nope. I equals N. I guess. I'm doing something wrong. Oh. No, this should just be 1. I minus 1. Has anybody worked this out yet? Probably not. Okay, if I 0. So I guess should go 5, 4, 3, 2, 1. It says right here what I was supposed to do, so I was thinking something different. So 0, okay. This should just be I. I should pay better attention to the hints they give you. Does this do it? 600. What is, I don't think that's right. Is that right? Let's see if it's right. Print 5 times 4 times 3 times 2 times 1. You actually don't have to do times 1 because anything times 1 is 1. Oh, okay, so I'm off by something. N minus 1, how about that? There we go. Off by 1. I was off by 1. Oh, wait, are we supposed to? Oh, okay, here it shows how to. Okay. 8. We don't need this anymore. 8 times 7 times 6 is what we're doing here. All right, so anyway, that's that. Shorthand operators. You know, is this the first time we've seen shorthand operators? Because if it is, I'm really sorry, because I've been using these all along. I get these. 148 is using a different textbook than 128, and they introduced all this stuff at different times during the book. So that could have been why I'm confused. But basically, what this is if you've got something like this, you can, you know, I equals I, some operator, and then some operand. You can condense it into, since you got I on both sides here, you can condense it and just take this I away and put the plus sign in front of the equal sign and just have the operand here. So it looks like this. You see, so you see what we've done. We put the plus sign over just to the left of the equal sign, right next to each other. And then you can get rid of that, and then you just have the operand there. So we have this. And this works for all the operands. Plus, minus, multiplication, division. It works for all you know, mod. It works for mod, and so that's why we can do this. So write a statement using that doubles the value of my var. My var, it doubles it. Minus 2. It's like my var equals my var times 2. You're supposed to convert this to equivalent, huh? My var, this is a weird one. Yes. Yep, this works because this is going to be evaluated first, and then we add it. And that's the correct order. All right, here's a challenge. Loops with variables that count. Okay, so we've got while, and so here we've got a program where we start with while with n equals 1. It goes up by 1 each time until it hits 4. So it's going to be 1, 2, 3, 4, and then it's going to stop. And each time it prints out n plus 2. So 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, like that. Okay, so what's next? Start. What's the output? 2 4 6. Well, that's nice. We're counting down 3, 2, 1, 0. 3, 2, 1, 0. That's 4 times, right? So, and each time we're doing minus 2. So 3 minus 2 is a 1. 1, 0, minus 1, minus 2. Because the last one is going to be, the last one is going to be 0 minus 2 is minus 2. Yeah, so is that right? Yeah. The next one is the target is 6, and we start at 3. So, and this goes up by 1 each time, and it goes up to and including the target. So it's going to be 3. It's going to be 3, 4, 5, and 6. That's 4 of them. And so, and each time it's going to start out at 3. 3 times 2 is 6. So each time it's going to be 3, 4, 5, 6, and each time it's going to be times 2. So it's 6, 8, 10, 12. Is that what it would be? Yeah. All right. Let's do the last one. We're going from 1 to 16, step 4. So we're going to start out at 1, and then we're going to do, step is 4, and we're adding steps. So it's 1, and then 5, and then 9, and then 14, and that would be it, right? And each time we do 2. So 2, 5 times 2 is 10. And then it's 1, 5. I'm going to use my little whiteboard here. So in this case, where did we get? I'm doing this. So 16, we're going up to 16, and we're starting out at 1. So we're going to have 1, and then 5, and then 5 plus 4 is 9, and then 9 plus 4 is 13. And then next time it comes around, it's going to be 17, and that's too high. So this is going to be, and each time it's times 2, right? Each time we're going to print out what n is times 2. So that's why this time we print out times 2 equals 2, times 2 equals 10, times 2 equals 18, times 2 equals 26. I think 26 is as high as we go. 18, 26. 26. Yeah. Oh, good. Did we get all the points? Yeah, we did. Okay, very good. Okay. Next challenge activity. Write a loop. Write a while loop that prints from 1 to whatever this is. We're going to read it in, increasing by 1 each time. What? What's so challenging about this? Okay, wow. While I is less than or equal to 4, print I. Less than or equal to user num. Oh, I gotta put something someplace. Wait. Oh. Oh, look what I forgot to do. What's what? That's what. Program end never reached. All right, let's try this again. Okay, looks like I got it. Okay, very good. What's this challenge activity? Retype and run. Note incorrect behavior. Then fix the errors in the code, which should print num star asterisks. So, all right, so we have some code here. We want it to look like this, I guess. And we want it to go here somehow. And we're supposed to fix it. So, while num printed is, let's make this less than or equal to num star. And we're going to print that, and then we have to increment. All right, let's see what that does. So if num stars is 3, starts out with 0, and is 0 less than or equal to, I think it's going to be like this. So while num printed is less than 3, it starts out at 0. So there's going to be the 0th one, the first one, the second one, and then if num stars is 3, we want to print out 3. So it'll be, so we don't want to have one of those off by 1 errors. So the first time, so we start out with num printed. And num stars. So the first time num printed is 0, and it goes all the way down. It's still 0. It prints an asterisk, and then it increments it to 1, and then it tests. It tests before it prints. Yeah, it always tests before it prints. So it's going to test right here. And so it comes down and it's dunt, tests. It's less than num stars. 0 is less than num stars, so it prints an asterisk. Then it increments to 1. then it tests again, and 1 is less than 3, so it prints an asterisk, and then it increments to 2, and then it tests, and 2 is less than 3, so it prints an asterisk, and then it goes to 3, and it tests, and 3 is not less than 3. 3 is not less than 3. So this is not executed. So it skips down. So then we're done. So there is not an asterisk printed there. So we just end up with the 3 asterisks. So that should be the answer. Yeah, it is. All right, very good. Okay, so let's look at for loops. It's only 403. So so a for loop statement loops over each element in a container one at a time. It's an interesting way of putting it. Assigning a variable with the next element that can be used in the body loop. The container for the loop is typically a list, or a tuple, or a string, or a range. Doesn't have that here. Each iteration of the loop assigns the name given in the for loop statement with the next element of the character. So they're talking about this. So we have this character container. It's got a bunch of things in it. It could be a bunch of letters from a word. It can be a tuple that's got elements in it. It could be a list. It's got some elements in it. So it starts out with the first one, and then it does the second one, third one, fourth one, until it's done, and then it's done. Okay, so you don't have this this infinite loop problem where you accidentally don't put in the incrementing thing. You don't put in the thing that's going to change the condition to false. You forget that, and then the loop runs forever. You don't have that because it's all controlled with this for structure here. Right, now you can still get into an endless loop with a for loop. This is off on a tangent. You can still get into an endless loop if somehow if each time in the loop you add something to the container. Now, I don't know if that's how it works in this language, but in other languages you can cause an infinite loop if you cause the condition of the for loop, the termination condition of the for loop. If somehow you're messing around with that in the body of the loop, which you shouldn't be doing. All right, so here, for example, we're going to loop through, and each time name is going to take on an first time through name is going to equal Bill, and the second time through name is going to equal Nicole, and the third time it's going to be John. And so each time we print out name here, and so it does this. See that? Here we have a list of dictionary keys. It's MTV is 35, CNN is 28. It's someplace in the world, these are probably the right numbers. And so for each C in channels, now C is going to be the key, and channels is this whole thing, and channels of C is going to be whatever this is. So C is this, and channels of this is this. Channels of MTV is this. Channels of NBC is this. So that's why channels, this is the C, and this is the see, that is on channel that. So that is on channel that. Here we're use a loop to access each character of a string. So what we're going to do is we're going to take a string, looks like this, and we're going to loop through and we're going to create another string that's going to take each one of these characters one at a time, and it's going to append this onto it. So basically what this is doing is it's taking each character and sticking it on there, but after it sticks on the character, it's going to add an underscore character also. So that's why you end up with something that looks like this. So it takes the T, puts the underscore. So there's an underscore under each one, and there's an underscore at the end because the last character, the period, is going to append on an underscore at the end. So you've got that at the end too. And then we print out the string. So kind of a dumb example. Iterate over the given list using a variable called myPet. Copy, paste. Iterate over a list of my prices using a variable called price. So for price in my prices, yeah, that's right. Iterate over the string 911 using a variable called number. For number in 911. All right. So here's some examples of using for loops. We just have a list here. Of these numbers, and so we're going to iterate over this daily variables, daily revenues list. Each time, starting with the first one, we're going to call that day. And each time we're going to add, we have a total, starts out at 0, or each time we're going to add day, add the day. And here we go. This is the number of elements in the list, the length. And so this is how you would compute, this is one way of computing the average. So first you got to add all these up, and that's what this does. And then you're going to divide it by the number of elements, and that's what this len function does. This iterates over a bunch of names, and then it prints them out with a vertical bar after it. So we got this here. Oh, look, reversed. Well, that's nice. So this iterates the reverse way, apparently. Total equals total plus num. All right, challenge activity. Looping over strings, lists, and dictionaries. So here we have a program where we got a list, and we're going to iterate over them, and so that's why that looks like that. So let's do the next one. Maybe I won't do all these. We'll just start. Okay, the first one. For each number in numbers, print number. Yeah, okay, whatever. That's easy. 8, 3, 4, 6. All right, let's do the next one real quick. Word Python. Char in Word. This is the word. We're going to loop over each character of the word, and we're going to call it char. And this is going to print out char followed by a slash. So we go P slash Y slash T slash H slash O slash N slash, and then we got to do this last print thing here, so it's done. And I think that's it. Okay, so you can do the rest of them. So this adds up the weights, prints out the result. Anyway, okay, what's the next challenge activity? Write an expression to print each price in stock prices. An expression for each stock. Is that all? Okay, I guess it's for price in stock prices. Is that it? Oh, I guess so. That was pretty easy. All right, what's this one? Printing a dictionary. Write a loop to print each contact in contact emails. For example, sample output with inputs alf at hmail.com. Write a loop to print each contact in contact emails. Okay, so we got three of them in here. We've got Susan Rain, and we've got that's this one here, Sue Rain. We've got Mike Filt, and we've got Nate Artie. And then we're reading in a new one, and we're adding it to the list contact emails list. Dictionary. This is a dictionary. Okay, so we're supposed to write this? Okay. For contact in contact emails, I guess this is right. Emails is contact. Okay, it doesn't have to be contact. It can be C. I'll do this way. And we're going to print contact emails contact is contact, I think. Okay, so this is just going to loop through all the content. Okay, this is first going to add, okay, so we have this existing list. Here we read in a new one, and we put that into the list, and as a dictionary. Put that into the dictionary. So now we've got 4 of them. Can I mess with this? I guess I can't. Okay. Run. Yeah, it worked. Great. Wonderful. Okay, let's I was gonna mess with this one, wasn't I? We don't have range yet, do we? No, we haven't covered range yet, so I can't yet use this. So let's quickly go over range, but I might go to the end. That's fine. All right, so there's this range function. And this range function defines, a range, a starting and an ending, and it's just a it's a sequence. It's just a sequence of numbers of integers. So range. Okay, so we're commonly use specific iterations, and loops commonly use iterate over elements of a container. The range function allows counting in for loops. So range generates a sequence of integers between a starting integer and that is included in the range and an ending integer that is not included in the range. You'll see what that means in a moment. And it increments, the default increments is by 1, but you can specify. Okay, so here when we say range y, that just generates a sequence of all non-negative integers less than y, assuming this is a positive number. So range 3 creates a range 0, 1, and 2. So the lower one is default. So it never includes the top one. It always goes right just up to the top, but not including the top one. So x and y, so range x comma y generates a sequence starting with x up to but not including y. So all integers greater than or equal to x and less than y. So here, for example, a range of -7 to -3 includes -7, and -6 and -5, 5 and -4, but it does not include -3. So now this one here specifies an increment value. So here we're going x to y, and each time we increment by z. So it's this is it's like this one here. Start out at 0, we go up to 50, but each time we go by 10. So 0, 10, 20, 30, 40, and then it does not include 50. Here we can, z can be negative, and in which case we're going down. So here we start out with this one. That's in the set. We apply this to it, and we keep on applying it to it until we would reach that or pass or go past that. So here we see a bunch more examples using the range function. See, here we go from 0 to 5 by 2. So we do 0, 2, 4, and then we're done because the next one is 6, and that is greater than or equal to 5. So here we're going from 5 down to 0, starting with 5, 4, 3, 2, 1, and then we don't include the 0. So, here's the same calculating yearly. This is what I was going to do here. So this is the same program, isn't it? Initial savings of 10,000. Interest rate is 5. Interest rate set. Input the number of years. Well, here we're printing this out. Input the number of years, and then we set initial savings equals initial savings, and then here we're doing 4 I in the range of these years. You see, so that all we're doing is replacing. So all we're doing is, well, first of all, let's see that this runs. Enter number of years. Let's go 5 years, and we get that. Okay. So so let's just replace this. It's all the same. We're just going to do for I in range, left parentheses, and I'm going to put a right parentheses here. And let's goofy, but who cares? And now I'm going to save this, and I'm going to run this, and I'm going to go 5, and lo and behold, it works the same. See? So that's a good example. All right, it's where are we now? I might as well finish this section, and next time it's while versus next section will be while versus for loops. But let's just finish this so we can say we finished covering it. Okay, so I could go while I less than or equal to 5 years. Okay, that goes up to 7. This might go. Oh. What did I do? What was there? Oh, what did I have here? Oh, I do not need this. In this example, I would not need that, and I would not need that. So I do not need this. And I do not need this. It still works just the same. Fine. Right. So here I need to put I equals 0, and I need to put I plus 1. And now it's going to work. Very good. That goes up to 7. Okay. Goes up to 7. All right. So anyway, what sequence is generated in range 7, 0, 1, 2, 3, 4, 5, 6? That's this one. What sequence is generated by this? 2, 3, 4. Write the simplest range function that generates the appropriate sequence of integers. What? Range 501. I don't know what that is. Oh yeah, okay. This would be range 10, comma 21. Is that right? Oh yeah. Every second integer from 10 to 20. Range 10. Now do I put 20 or 21? Gotta be 21. Because you want to include 20. According to this. Yeah, okay. Integer 5 down to minus 5. Range 5 minus 6 minus 1. okay. What's this challenge? Enter, is that the last one? Very good. Enter the for loops output. Okay, so, okay, great. Okay, let's start. For I in the range of 3, what's the output? Well, I guess it's going to be 0, 1, 2, he thinks. Sometimes I got to put the space there, and that's just this thing. All right, what is this one? Print I. Okay, so first thing it's going to print is I starts at 0. So 0 times 2 is 0. And then it's going to be, so it's going to be 0, 1, 2, and 3. So 0, 1, 2, and 3, but it's actually times 2, so it should be 2, 4, 6. Well, you can fix that. Anyway, all right. So I think we're pretty good here. Are there any? That finishes up our beginning of the range and for loop. And so next time we're gonna talk a little bit more about the difference, and then we're gonna do some more. Then we can do some more of the exercises in the back. But the exercises in the back, they're all just while loops and for loops. And we did last time we did 514 and 516, and well, some of them I signed all of them, so that's good. Get good practice. We have a couple more while loop where the answer is best suited writing a while loop, and then the rest of them are for loops. But as we can see, we can kind of use either. So next time we'll do some more problems. That's next Tuesday, and so once we're done with this chapter, we should be. I mean, that's like all the main stuff, right? Let's see where. Yeah, then we get into functions, okay? And so loops is really the end of the construct. So we have branching, we have looping, we have assignment statements, and that's it. Functions have to do with combining a bunch of code together so we can reuse it, where we group a bunch of statements together and call that something, and then we can do all those groups of statements together just by calling the name of the function. So after this, it gets into more, and then lists and dictionaries and strings and stuff. That goes more in depth into the kinds of built-in functions. These get into methods and so on that can operate. Like you can sort a dictionary with just a single method call and so on. And then classes it's like functions, but with classes. Oh, these are not functions that we write. This is functions that, oh no, user defined. Well, we can write functions, and then in classes also contains, wait a minute, I might be getting something funny there. Are these just like built-in functions or something? Oh, no, it's not. Okay. Okay, anyway, so I'll leave it there, and we'll see you next Tuesday. Are there any questions? Yes, you can email me. If you have any questions about any past activities, just email me and I'll answer you directly. All right. Thank you. See you next time.